Alright, in this video what we're going to do is we're going to do translations of y equals 1 over x, and this is, say, part 2. So for this example, we start by sketching the graph. So for A, start off with our essential function y equals 1 over x. Okay, so one thing we see is that there's a vertical asymptote which is x equals 0, and there's a horizontal asymptote which is y equals 0. Okay, so y equals 0 is the is the x-axis. But now what we're going to do is look at this graph, 1 over x, the whole thing plus 2. And what is adding 2 to the graph? That shifts the graph up by 2. So you take this same graph and we just translate it, rigid translation, moving it up by 2. So it's, of course, there's issues of what you consider the scale to be. I'm going to mark it like I'm showing here. So I'm going to say this is y equals 2, and that becomes, okay, so here's the graph I'm setting up, and I have this horizontal asymptote. The horizontal and the vertical asymptotes are what we're focusing on when we sketch these types of functions, which are rational functions. Okay, so we've shifted that up by 2. Okay, so let me see if I can get them both on the same screen. I have y equals 1 over x over here. I add 2, and it shifts it up by 2. All right, now this is the thing that I want to point out. Note that y equals 1 over x plus 2 is equal to what? Well, if I get a common denominator, this is 1 over x plus 2x divided by x. So this makes y equals 2x plus 1 divided by x. I changed the order, I put 2x in front. So here, what I have is I have this polynomial, or sorry, this rational function where I have a polynomial in numerator and denominator, and they both have the same degree of 1. Now, if I'm given this guy right here in this form, how can I get to this form here to see the translation? I could do long division. So let's, and also notice they have the same degree. The degrees are equal. And notice that the horizontal asymptote is 2. That is the coefficient of the lead coefficient here of this polynomial. So it's 2x plus 1. The lead coefficient is 2. And in the denominator, I have 1. So it's like 2, it is 2 over 1 makes 2. So there's a little rule to finding horizontal asymptotes. We look to see if they have the same degree, the numerator and denominator. And if they do, we take the lead coefficients, and what's the lead coefficient is the coefficient of the lead term, which is the highest degree term. So I take the highest degree term, which is 2x, highest degree term, which is 1x, and then I take 2 divided by 1 and get 2. That gives a horizontal asymptote. I know I said that. Maybe I can write it down another time. Okay, let's just do one more, although it might be more difficult, but let's try it out. So suppose I have y equals 3x minus 1 over x plus 1. So what I'm going to do is I'm going to first do long division. Now, it's a sort of a question if this is practical to do, actually work this way because long division is a little bit of trouble. But it's still interesting to try this. Okay, so when I do long division, I'm going to say, well, 3 times x makes 3x here, so I'll put the 3 there. And I'll get 3x plus 3 when I multiply. And then I subtract, which is the same as adding the opposite. And that gives us minus 4. So what do I do with this remainder? I take that remainder. I have minus 4 over x plus 1. So in fact, our function is negative 4 over x plus 1 plus 3. So this is a shift up by 3. This is shift left by negative 1. And then, a little bit confusing, but this is a reflection. About the x-axis. So let's just break this into little pieces. Y equals 1 over x. Tiny pieces. And then maybe you don't have to show all the work on this every time, but it really doesn't hurt. Okay, so that's y equals 1 over x. Let's then look at what happens when I multiply it by negative 4. Okay, the negative is what I'm going to focus on. The negative flips it over. 4 is going to stretch it out too. So if you multiply a function by 4, it's going to stretch it out. But multiplying by negative, and that gives this. Okay, just a little too much. Well, let's keep going. Let's just do this. Okay, and then I replace x by x plus 1. That gives a shift to the left of this graph by 1. So now I have the vertical asymptote of x equals 1, and it's going to shift. Now the thing is, it sort of isn't. I think it might look better if I think about what the y-intercept is. So I mean, you can plot some points. Like if you put x equals 0, you can see that when x equals 0, y equals negative 4. It just makes it look a little better if we try it a little bit harder on something like that. So actually, if you have negative 2, then we'll get 4. So where am I? Well, that's correct. It's just sort of now getting a little bit messy. Okay, so now let's finally do the last one. I'll just see if I can sneak it in over here. Negative 4 over x plus 1 and add 3 to that. So I take this graph. The thing is, I started getting too much into plotting points, I think. So, okay, I'm going to shift to the left by 1. Okay, so the vertical asymptote is x equals 1. So this is vertical asymptote x equals, this is x equals negative 1. And then I'm shifting this up by 3. So it seems like I'm thinking too hard. Just now I'm getting tired and making mistakes. Okay. And then, roughly speaking, well, again, I could put in numbers though. Put in x equals 0 and I get negative 1. And I sort of want to know in this whole... Okay, anyway, let's just do that. Well, that's it. I'm going to redo it, though. I feel like I need a bigger canvas. Not only that, I'm sort of tempted to plot points to really get this right. The thing is, when I flip the page, I forgot what function this is. So this is y equals 3x minus 1 over x plus 1, which we found out this is equal to negative 4 over x plus 1 plus 3. So we have a vertical asymptote here of x equals negative 1 and a horizontal asymptote of 3. And then we can just plot some points, even though I sort of wanted to avoid that. But especially, let's put in x equals 0. And we get negative 1. And I don't know, let's put in 1. And that's going to give us 1. So this is what our graph looks like over here. And then on the other side, it should look something like this. And so this is our vertical asymptote. X equals negative 1. And our horizontal asymptote is y equals 3. All right, so that's that.